Alrighty, guys, so going back to those 4.5 notes, reciprocal functions, that's what our warm-up is over today. I want you to set a timer for 5 minutes and complete this, and then we will go over it together. Okay, so how we start these problems, and hopefully you got a little refresher if you looked back at your notes. Maybe you were able to do this without them, which is good. It might mean you did your homework too. So when we are talking asymptotes, that's where we start these. We are dealing with those A, H, and K, right? So H is going to be what we deal with for our vertical asymptote. And if we remember, that is the number that is down here with the X. We also have to remember that that one is the deceiving friend. So if it looks like a -5, that vertical asymptote is actually going to be X equals 5. Okay? Moving right along to our K value, which is going to help us with the horizontal asymptote. That's a good friend. It always looks like exactly what it is, tells you straight up. So Y equals -1 should have been that horizontal asymptote. Okay? After knowing these, we're able to go ahead and do the domain and the range. So for domain, the only stopping place we have is 5. It's the only X value we have to worry about for right now. So we should have -infinity to 5 and 5 to infinity. Same thing with range, but the only value we're stopping at is -1. So -infinity to -1, union with -1 to infinity. Okay, cool. The rest of these blanks, we've not talked about them yet specifically for these types of functions, but these ones right here, you've definitely seen for other types of functions. Since we never talked about holes for reciprocal functions, you're safe to assume that these don't have any, and they don't. We would have talked about them if they did have them. So just put N/A or none for holes on these. We will get into what those mean today in 4.6. We're good to go ahead and draw our table now. So that is the next thing we do know how to do. We build our table around our X equals 5. So we put the 5 right there. We need 2 numbers to the left, 2 numbers to the right. You should have used 3 and 4, 6 and 7. And then we go to plug these in. Be careful when you plug them in, okay? When you do, you want to put that denominator in parentheses, just so that way your calculator does not give you any weird numbers or any domain errors. So we're typing in 1 divided by, parentheses 3 minus 5, close parentheses, -1, and you should get -1.5. And then we go back and we change that 3 to a 4, and we get -2 to a 6, we get 0, and to a 7, and we should get -0.5, okay? We also know how to graph those asymptotes as well as those points. So X equals 5 should have been, again, it was a vertical asymptote, so it should have been a vertical line through 5. Y equals -1, horizontal asymptote through -1. Remember, these lines are dashed, so make sure you do that. And then we plot them. So 3, -1.5, 4, -2. One really good question that I got last class was, do I start from the center of my asymptotes or do I start from the origin when I'm plotting these points? You always, always, always start from the origin, okay? The origin's not a point on this one, but start from there when you're plotting the points. Don't start from your center right here because that's not correct, okay? Now we're able to draw our lines. We got to stay within these boundaries that we've made with our asymptotes, and our line should look, our graph should look like this. Okay, good deal. And now for the grand finale here, we're going to fill in the rest of these blanks that we've not talked about yet for these, but they are pretty simple, relatively easy. So we'll start with the limits. When we're talking limits, the X approaches are going to be -infinity, +infinity. And most of the time, that's what they were last semester too. If I were to if I were to follow this graph, if I follow X to the left forever, okay? If I'm doing that, it doesn't matter which piece of this graph I even look at, but if I go left forever, what is Y doing? If I'm moving along both these graphs going to the left, and you should see that Y is actually going up, so we're going to call that +infinity, because that's what it is. And then same thing with as x goes to the right forever. So we just want to follow these graphs. Ignore these highlighter marks. I'm just showing you, since I'm not there in person to show you. As I move right on this graph, whichever direction, which way is y going, and it is going down in this case. So we'll call that negative infinity. Okay, and then we have our roller coasters, those increasing, decreasing intervals. The good news is you're only going to have one or the other on these. Okay, so if I followed this, if this was a roller coaster from left to right, again, it doesn't matter which piece of this graph I'm riding, if I were riding that roller coaster, but we can see that they are both going down. Okay, so we're going to have a decreasing interval only, meaning no increasing here, and we're just going to copy the domain. Okay, and then last but not least, x and y intercepts. First thing I want to do is go to my table, see if I got any freebies. I did. I got 6, 0, and if I look at that, that's an x-intercept. Perfect. And then a y-intercept. Am I crossing the y-axis? I absolutely am, but I don't know what that point is. But the good news is, if I know I'm looking for a y-intercept, that's when x is 0. Okay, so I can just go plug in 0 for x, which happens to be pretty easy here. I just do 1 divided by 0 minus 5 minus 1. And when I do that, just go plug in 0 to my function, I get negative 1.2. Okay, so that is how these work. Get that copied down, and we're jumping right into 4.6. Last day of this section, so that's super exciting for us, okay? I know that this unit has been kind of long. That test is approaching, but I don't think you'll find this stuff to be too stressful. It's just the beginning, this little chunk of notes that tends to be a little bit overwhelming, but feel free to go back and watch this video if you need to after you learn this, okay? So last class we graphed reciprocal functions. Those were the ones that dealt with a, h, and k, okay? Now we're going to be looking at other types of functions dealing with rationals like fractions, okay? But these are going to be in the form of polynomials. So in this box up here, how this is going to look, it's going to look like f of x equals, and then we're going to call this p over q, p of x over q of x, okay? P and q are both going to be polynomials, meaning if they can be factored, I got to factor them, okay? And the other thing that's important to note here, if you think about it, and we've talked about this already this unit multiple times, q can't be a certain number. It can't be equal to a certain number. And the reason for this is because it would make this fraction undefined, and hopefully you're thinking of this in your head, but q cannot be 0, okay? Because if q was equal to 0, this fraction would be undefined and we couldn't graph it at all, okay? So those are two important things to note. And then now we get into the steps of graphing. So we had it pretty simple in 4.5 with a, h, and k. This is a little bit more complex. First step is going to be to simplify, okay? We couldn't simplify with the reciprocal functions. There was no crossing anything off, factoring. Again, we got off pretty easy with those. But here, there might be some factoring. Might not be, okay, but there might be. So we do want to check for that. That's step 1. Okay, step 2 is going to be to find the x-intercept by setting the numerator equal to 0. So we can set p of x equal to 0 and find the x-intercept. If you don't remember that, it's okay, because at the end you can come back to that. We know x-intercepts are when y equals 0 too, right? So if we forget that little step, not a huge deal, but we are going to learn it just because it is a nice little shortcut that we have, okay? Moving on to number 3. This is super important. Okay, I would highlight this, underline it, whatever you got to do. The vertical asymptote we find by setting the denominator equal to 0. The bottom part equal to 0. That q of x equal to 0. Okay, that's how we find the vertical asymptote. You do need to know that. Okay, and then we get to step 4. Okay, definitely the hardest part of this that you have to know. And after I go through this, I'm going to show you kind of like a little like stupid, cheesy thing that my students made up last year that helped them. And we'll kind of talk through that. But first, we're just going to fill in this box. So we find the horizontal asymptote by using these rules, okay? And they are changing depending on the problem that we have. So we're looking at the degree of the numerator and the degree of the denominator. And when we're talking degree, you might want to write this over here if you don't remember what that is. Degree just means the highest exponent, okay? So the highest exponent on top, the highest exponent on bottom, those are your degrees that you're talking about, okay? Perfect. So if the degree of the top is bigger than the degree of the bottom, this just means no horizontal asymptote. Won't have one, okay? If the degree of the top is less than the degree of the bottom, this means that your horizontal asymptote is y equals 0, which is also just your x-axis. Once you graph that, you'll see that, okay? And then the last case is if the 2 degrees are equal, okay? If this happens, that means that y will equal your leading coefficient of p divided by your leading coefficient of q. And leading coefficient, again, is just the number in the front, okay, the number in the very front. Okay, so last step then is to identify any holes. We'll talk about that in a second. With step 4, definitely a lot of info here, okay? And you're probably thinking, how the heck am I ever going to remember this, okay? So here is what my last year's students made up, and it did help. So hopefully it helps you. It is very corny, though, so I'll give you that warning. So the first case scenario, let's talk about horizontal asymptote. Starts with an H, okay? I'm a realtor. I like houses. So we're going to actually just pretend that the horizontal asymptote was a house, okay? So we've got this house. And since P is referring to the numerator, we're going to call that the top story of the house. And then since Q is referring to the denominator, that's going to be the bottom story, okay? So first case scenario is degree of P, okay, is bigger than degree of Q. So again, we're talking exponents, but let's say that the top story of your house, I'm a terrible artist, so just fair warning. The top story of your house is bigger than the bottom, okay? Guess what? The house comes crashing down, okay? Not really always, but that's just kind of in our mind what we're going to think, because that doesn't really make sense for the very top story of a house to be way bigger than the bottom. So that means no horizontal asymptote. We don't have a house anymore, okay? Cheesy, I know. We'll keep moving on. Second case scenario. First story is smaller than the second story. So degree of P is smaller than the degree of Q, meaning that here's P and here's Q. Well, last year's kid said that's pretty typical. Okay, we'll call that 0 fun. Okay, that's 0 fun. Most houses are that way. If you got a 2-story house, typically the second story is going to be smaller than the first. Okay, so y equals 0, 0 fun. Haha, get it, write it down. Okay, and then the very last case scenario is when we have the degrees equal to each other, meaning that top story of the house is the exact same size as the bottom story, okay? When this happens, we're going to kind of think of like an apartment, right? Okay, typically apartments have the same stories on the top and the bottom are the same size. So if this were the case, you would need to go out to the front yard to walk your dog. I know it's cheesy, okay? But this is the leading coefficients where those come in. So the numbers in front of P, the number in front of Q, that would be your horizontal asymptote. So when the 2 floors are the same size, equal to each other, we go to the front yard, okay? That is how we're going to remember this, okay? That's how we're going to do it. So Last step then is to find any holes. So we said in reciprocal functions we didn't have holes, okay? If we have a hole, you're going to know it from the beginning. I hate that they put this as step 5. I would put it as step 1, okay? Because after step 2, because after I've factored, if I cross off a common factor, which is when the holes happen, ta-da, I have a hole. I'm going to go ahead and define it then. Knock it out of the ballpark, okay? But if I don't cross anything off in the beginning, there's no common binomials, then I don't have a hole, okay? And I can just move on from there. So, enough said. Now it's time to actually go through one of these problems. Okay, so here we go. How we are going to start this is we're going to first ask ourselves, can this be factored? And if I look, it cannot. Okay, there's nothing I can do on top, nothing I can do on bottom. They're not the same. So that tells me right there, I don't have any holes. So on the line that says holes, I'm going to go ahead and just put none or n/a. Okay, I don't have any. Perfect. Okay. Next thing, and this is if I remember to do it, I'm going to set the numerator equal to 0 because that's going to tell me my x-intercept. Okay, which is really nice to have from the beginning. So if I set x minus 4 equal to 0, x equals 4, that's just the point 4, 0. So that is my x-intercept. Perfect. I could even go ahead and put it on my graph because I know it's going to be on it. We're done with that. Okay. Then we have the asymptote. So this is where we get to the important part. Okay. The easiest one is the vertical asymptote, and that is because it's just the denominator, set it equal to 0. Okay. Always, always, always. Denominator, set it equal to 0. It's got the x in it already, which helps me to know, hey, that's vertical, because I know my vertical asymptote is always x equals a number. And when I solve x plus 4 equals 0, I get x equals -4. Voila, that's my vertical asymptote. Okay, then we dive into the horizontal. Okay, again, horizontal, house. So we're looking at the degrees of this problem. Degree of the top, degree of the bottom. If we're talking degrees, highest exponent, we got a 1 and a 1. Those are the same. So this is when we think apartment, go to the front yard. Got to go to the front yard of the apartment. Okay, probably doesn't have a backyard. So go to the front yard. We are looking at the leading coefficients. So if I look, y equals leading coefficient over leading coefficient. Those are invisible ones. So what is 1 divided by 1? It is just y equals 1. Okay, perfect. So now I have those asymptotes, which I am free to go ahead and draw because I know where they are. Vertical and horizontal. And I can go ahead and do my domain range too, because I know that domain only has one stopping point at this x value, -infinity to -4. Whoops, -4 to infinity. And then my range is -infinity to 1 and 1 to infinity. We'll go ahead, just the same as what we did last class in 4.5, we do that table. The only thing that's going to be different about this table, I'm still building it around that vertical asymptote. So still use that -4. These graphs can get a tiny bit harder to kind of tell where they're going. So that is why my best piece of advice is instead of doing 2 numbers to the left, 2 numbers to the right, I typically go 3. Okay. Is this necessary? Not always. Sometimes you can tell what it's going to do with 2. Okay. So I'm not going to dock points off if you only put 2 to the left, 2 to the right. Okay, that's not what I'm here for. But if we do 3, we'll get a better picture of this. It'll be a little less confusing. Okay, so I'm going to do 3 just to show you that. So we type these numbers in. That's how we're going to find y. Okay, when we type in, my biggest recommendation for you, put the binomials in parentheses. So in my calculator, I would go type in -7 minus 4, close parenthesis, divided by -7 plus 4. And when you do that, you should get 3.7. So everybody take your calculator, go type that in exactly how I wrote it here, and go make sure that you get 3.7 if you round. Okay? If you don't, try to have a neighbor help you here. Okay, now we're gonna fill in the rest of this table. So I'm gonna have you pause the video for like 30 seconds, fill in the rest of those numbers. Okay, you should have got 5, 9, -7, 3, -1.7. And then we just go and we plot those. Again, starting at the origin and then going from there. Okay, so there is my top section of my graph. It's going to look like that. And then my bottom section is going to look like this. And I had my x-intercept plotted, so I actually got 4 points on that one. Good deal. Okay, not the most beautiful thing you've ever seen, but it works. Okay, and then last but not least, we got to fill in the rest of these blanks. We'll go quickly. X approaches -infinity and +infinity. Where the heck is y going? So if I were to trace either of these pieces, as x goes to the left, we can see y is going down. As x goes to the right, y is going up. If this was a roller coaster going from left to right, y would be going up both times. So we're going to call that increasing interval and just copy the domain. That is it. Not going to have a decreasing. And then lastly, y-intercept. I can see I am crossing the y-axis. It's not given to me in my table, but that's okay because I know all I got to do is plug in 0 for x. Okay, it's a y-intercept. So I'm going to go and I'm going to plug in 0 here. So in my calculator, parentheses, 0 - 4, close parentheses, divided by 0 + 4, and I should get -1. Okay, that's it. So a lot of talking, a lot of info there. I'm going to set you loose to do example 2, so let's go there. Real quick before we start this one, before I turn you loose, I want you to look at this and tell me, can it be factored? Okay, and if we look, we know that the top can, so we can take out a 2. We're left with x - 3 on the top over x - 1. But can anything be crossed off here? Is anything there the same? It is not. So this is another one that's not going to have any holes. So it's going to work a lot like example 1. Okay. So I want you to go ahead, pause the video, take about 5 to 8 minutes, depending on how much time you guys need, and then come back here and we will solve this one together. Okay, so asymptotes is where I like, well, actually, we'll start with the numerator because hopefully some of you guys saw that. If I set the numerator equal to 0 and solve it, it really doesn't matter if I use the factored one or the non-factored one since I wasn't able to cross anything off here. Either one I can set equal to 0, but if I do that, divide the 2 over 0 divided by 2 is 0, so x - 3 equals 0, and then we want to add 3 over, so x equals 3. That would be my x-intercept, so 3, 0, okay? So that is the x-intercept. Then we're moving on to the asymptotes. That's really the important part. You could have came back to the x-intercepts at the end, and if you did, that's fine. But moving on to the asymptotes here. So vertical asymptote, super important one. Set the denominator equal to 0, and x equals 1. So that's what you should have got for your vertical asymptote. You could have went ahead and plotted it. Hopefully you did. Horizontal asymptote. So we're talking houses now. My cup of tea here. So we go, again, this one you didn't cross anything off. I'm gonna erase my circles here. We didn't cross anything off on this one. So therefore, it really doesn't matter if you look at the original or the factored one. But we'll just look at the original for now. So if we look, the degrees are the same, which is what happened last time. We think of this as an apartment. So that means go to the front yard. And when we do that, 2 over 1. That's what y equals. And that is 2. Okay. So in that case, we plot that asymptote, okay, and then we're good to go ahead and do our domain and range. So domain, you should have put negative infinity to 1, 1 to infinity. Range should have been negative infinity to 2, 2 to infinity. Okay. We'll go ahead and save the rest of this for after we do our table. So we'll do our t-chart. Building number should have been 1. To the left of that, you should have had 0, -1, -2. To the right, 2, 3, 4. When you plugged those in, you should have got 3.3, 4, 6, -2, 0, and 0.6. Again, when you type these in, use the parentheses. So in your calculator, you should have typed, if you use the factored one, 2 parentheses, -2 minus 6, close parentheses, divided by -2 minus 1. And that's how I got 3.3. Okay, so make sure we're using those parentheses, because that is what is going to help us get the right answer here. Okay, I'm going to plot these points again, always starting from that origin number. That's how we plot points. Okay, so the top section of my graph should have resembled this, and then the bottom should be like this. Okay. Limits x approaches negative infinity, positive infinity. If I were to trace this, starting with going to the left forever, either piece, we can see that y is going down. So x goes right forever, y is going up. These are always going to be opposite of each other, by the way. Increasing and decreasing. If this was a roller coaster, left to right, it would be increasing. So we copied the domain. Decreasing is nothing. And then last but not least, the y-intercept, we do have one. And finally, my table gave me a freebie, which I love, 0.6. If you waited to find the x-intercept at the end, your table also gave you that one too, which is nice. Okay, that is it for this problem. Got one more problem that we are going to do together. But ask your neighbor if you have any questions, or send me a message on Canvas if you have questions on this one. Last but not least, we are going to move on to example 4. Okay, so here we go. From the beginning, can this be factored? Absolutely, right? We should notice very quickly that bottom can be x methoded. So we draw our x. On top we got 20. On the bottom we have 9. Think about it. My two numbers should be 5 and 4. So this is going to become x plus 5, x plus 4. And I'll go ahead and cross this out. Okay, so now can this be simplified? And your answer should be yes. If we have two of the exact same binomial, they are gone. So now this fraction becomes f of x equals 1 over x plus 4, which is actually awesome because that's really simple, okay? That's going to make the rest of this problem really easy, especially when I'm plugging in numbers. That's not a hard problem to plug into, okay? But we said from the get-go, if we have a common factor, that makes a whole. So that common factor there is x plus 5. So we're going to go down here. I'm going to write the word whole just so you know that my work here, that's what I'm doing. X plus 5 is the common factor. We're going to set it equal to 0. And x equals -5. Okay? We don't know what y equals. This is not an x-intercept. This is a whole. Okay? We don't know what y equals, but we do know what x equals. So we can go plug that x in to my equation. Go to the simplified one. We are now plugging into this. We are not plugging into this big one, okay? That makes no sense. We don't want to work backwards here, and that's, even though that would still get us the right answer if we plugged into the big one, we just don't want to do more work than we have to, okay? So for finding y for this whole, I'm just going to type in my calculator, 1 divided by parentheses, -5 plus 4, close it, hit enter. When you do that, you should get -1 for y. So this point for this hole is -5, -1. And I'm going to go to where -5, -1 is, and I'm literally going to draw an open circle. Because that's what a hole is. Okay. Good deal. Now we're going to work this problem the same way we worked the others, okay? But again, we're looking at this simplified guy. So, starting off, numerator, I could go ahead and set this equal to 0, I guess, and find that. I'm not even going to worry about that right now. We're just going to start with the denominator. We're going to get those asymptotes out of the way for now. So, x plus 4 equals 0. That's how I find the vertical asymptote. So that's going to give me x equals -4. Go ahead and graph it. It's really close to the hole that I put on there, which is fine. Horizontal asymptote. So this is the house thing. We go to our problem. Again, doesn't really matter which one, the original or this one, but we're going to go to this one. We're talking degrees, so we're talking highest exponent on a variable. Well, if I look, this one up here doesn't even have a variable in the numerator. Okay, we don't have any x's, so we'll assume that it's just x to the 0, because that would be 1. And then on bottom, we have an x to the first. Okay, so what happened when the top story of the house was smaller than the bottom story? P and Q. We said that meant 0 fun, right? That's no fun. So that meant y equals 0. Okay, so we'll go ahead and put a dashed line on our x-axis as well. Okay, now we get to the domain and range. This is really the only thing that the hole is going to change, is the domain and range. And the only reason for that is we now have one extra stopping point. Okay, so domain is always x's, range is always y's, don't forget that. But now we're talking for the domain, instead of just stopping from -infinity to +infinity, instead of just stopping at -4, we're also stopping at this x value of -5. So we want to kind of think about logically from left to right which one comes first. It's the -5. So -infinity to -5, close it. Okay, then we have another stopping point from -5 to -4. We're stopping at -4, and then picking back up and going from -4 to infinity. Okay, same thing with the range, but again, y values. So stopping at 0 and stopping at -1. So obviously -1 comes first. And that's what we got. Okay, now we're going to quickly build our table, x by t chart. Don't let the hole mess you up here. You're still building around your vertical asymptote, so we're still going to put that -4 in here. We're going to build our numbers around -5, -6, -7, -3, -2, -1. I'm going to pause here. I want you to go ahead, type those numbers in, use the simplified version, and then try to get the rest of this done. So give you about 3-4 minutes here. Okay, so on this table, you should have rounded here. We get -0.3, -0.5, -1, 1, 0.5, and 0.3. So -7, we're just going to plot these points now. Okay, -5, -1 was a hole, so I'm not going to fill that in. If you did, just erase that fill in mark. Because again, we got to leave that open. And then plotting the rest of these. Okay, it gets really close to that asymptote, but again, it does not touch it. Okay, x goes to -infinity, +infinity. As x goes to the left forever to -infinity, y is going up forever to +infinity. As x goes right forever, y is going down forever to -infinity. Okay, if this was a roller coaster riding from left to right, decreasing, right? So we should have copied the domain on the decreasing line, which unfortunately is kind of long. I'm running out of room. There we go. X-intercepts, looking here, I'm not going to have any, okay? If I have a giant hole, a giant asymptote on my x-axis, I'm not ever going to cross that. And then lastly, y-intercept, don't see it in my table, unfortunately, but that's an easy one. We just plug in 0 for x, so 1 divided by 0 plus 4 should have just given you 0.25. And that's it, okay? That is all I got for you today. Your homework is up on the table. It's odds only. You can also check Canvas for that. Let me know if you have questions. Work with your group today to get this homework done. And good luck. This is the last section of this unit, so we do have a test coming up. So please be studying. Please be getting help if you need it. Thanks, guys.